This is a pretty good question presented in Wei's exam of 2017 Math Specialist. The question is, given this complex equation 2z to the power of 6 equal to 1 plus root 3i, solve for z. The first thing we can do is divide both sides by 2. And we got to convert it into the so-called trigonometric form, which is going to be cis pi on 3. But now, this time the stipulation of this question is such that the angle must only be between 0 to pi on 2. With that said, let's 6 roots both sides of the equations. Z to the power of 6 is going to be equal to cis pi on 3 plus 2 pi k, as complex numbers are periodic, and we need to 6 roots both sides. If we were to employ Demoivre's theorem, we're going to get cis pi on 18 plus pi k on 3, such that k is between 0 and 1. Now, all we need to do is now solve for the roots, where omega 0 is going to be cis. If we put 0 into this k, we only get pi on 18. And omega 1 is going to be, if we put 1 to this equation, pi on 18 plus pi on 3 is going to equal to cis 7 pi on 18. Now for the second part, consider this complex equation 2z to the power n equal to 1 plus root 3i. The previous part of the question was 2z to the power of 6. Now it's going to be 2z to the power n, where n is a positive integer. Now, if 3 and only 3 roots lie in the first quadrant of the Argand diagram, if 3 and only 3, so we got 1, 2, 3. If 3 and only 3 roots lie in the positive Argand diagram, in the first quadrant of the Argand diagram, what are the possible values of n? This is a pretty good question, because we should know that the roots of a complex equation are fanned out equally as 2 pi upon n. So with that said, if this is omega 0, the first root, and this is omega 1, the second root, and this is omega 2, the third root, every omega other than omega 0 can be generated from omega 0. The first root must be, from the previous part of the question, where this was the original angle. But because we need to power of n, we get n in the denominator over here. And because all the roots are equally spaced as 2 pi upon n, omega 0 will have an angle here of pi upon 3n. And all of this must be contained within the first quadrant. That being said, because complex numbers, when we generate the roots, it always goes anti-clockwise. All of this must be less than pi on 2 radians. Because pi is a positive number, we can cancel all of this out, and we get 1 on 3n plus 4 on n is going to be less than half. And we get 1 on 3n plus 12 on n less than half. Reciprocating both sides, we're gonna get where 26 on 3 itself is gonna be 8.666 recurring. Now, because n has got to be a positive integer, the first integer greater than 8.6 is going to be 9. Over here, what we have is that we found the lower bound of all possible powers. Now for the upper bound, back to this diagram here. Where omega 3 could be, it could be on the imaginary axis itself, or it could be anything more than the imaginary axis. With that said, the original omega 0's argument is going to be pi on 3n plus omega 1, 2, 3 is going to be encompassed by this piece. And all of this must be greater than or equal to pi on 2. Cancelling out the pi's. Reciprocating. And 30 on 3 can be written as 12.66 and so on. And so the integer which is less, the first integer which is less than or equal to 12.66 is n equal to 12. So we found the upper bound of what n could be. So therefore n could either be n equal to 9, 10, 11 or 12. These are the 4 possible solutions.